Recording in progress.
Okay, hello everyone. Welcome to another Wolfram language design review, part of our language completeness and consistency series. And looks like we have two topics for today. First one looks complicated. The second one, famous last words, looks fairly easy. All right, manipulating held expressions. Okay, now we also talked about this yesterday in connection with the compiler, and this concept of a purely what we were calling yesterday structural. Did we finish on structural expression, or did we have a different name for it at the end of yesterday?
I should look back. I think it was structural expression, but either way, I think it kind of concluded that this was not something that can really exist in the value.
Chris, you disappeared into the video.
Yeah, you disappeared, or audio disappeared.
Can you hear me now? Hello?
Yep.
That's weird. I was just saying, I think I needed to go back and check, but I'm pretty sure we did settle on structural expression or something like that. But we also, I think, concluded that it's not something that can exist in the evaluator.
Yeah, we decided that structural expression will be an unevaluated blob with respect to the top level. So it is therefore not directly relevant for, let me see, do I have an LCC? Yes, I do. It's not directly relevant for this, but it might be. Okay, so what we have here is I really probably should stop.
So I was not part of this conversation yesterday, but I think that might be related to the third bullet point of those three major points of something that we discussed, at least in passing last time, right? The symbolic inert representation of symbolic expressions.
Yes,
right?
But I think what we're imagining is, in compiled code, you can write, for some reason, 2 plus x was our example thing. Let me just save this in the right place. I think we had a whole section for held expressions, did we not?
Avery?
Did we have a section here? For
I think it was called code transformation.
Oh, right. So we had
folder.
Yeah, we have a code transformation folder.
Okay, so let's say, let's just start off with the SW notes 01. Okay. All right, so the concept is, in compiled code, this would mean create a data structure which is an expr struct, which you can then manipulate. And the other one of these we had was structural evaluate, is that correct? Which is in compiled code, within compiled code, compilable code. These are things, and then there's a structural expression data type, also within compilable code.
And there's another one to construct, like to compound them together to create compound expressions from pieces.
Wait a minute, we didn't discuss that yesterday.
That's just the function construct.
That's maybe the function construct. So, but that's.
I mean, there are a whole bunch of functions like construct and apply and map and so on that,
Right, the need to operate on structural expressions.
Yeah.
Right. Where their type signature involves structural expression in, structural expression out.
Yeah,
correct.
Just like the ones with numbers in and numbers out and so on.
Correct.
Okay. All right, so
we're talking. So, well, I guess is this a normal expr, or is this
Yeah,
it's just this is the expr struct in MC code, no more and no less. And you can do similar things in compiled code that you can in MC code, if that's helpful, Itai.
Right, but I guess my question is, we're talking about how construct and map will behave specially, so it won't treat it like a normal expr?
Oh, no.
Well, there is no normal expr. I mean, it's
second argument is a list, a normal expr. It will make another version with the head threaded down. So applying the function.
The only point here, Itai, is that when you compile construct, just like if you compile, I don't know, plus, and one of its arguments is a list of integers, it will then generate another structural list of integers as its output in the compiler. So here, this is taking a structural expression in and generating a structural expression out.
Correct.
I mean, the point is just that it's the same as in kernel C code. You know, if you imagine having a construct function in kernel C code, you would apply it and it would make a new expression, but it wouldn't evaluate it. And then only
It's basically
by calling I eval.
I haven't touched. Yeah, I haven't touched that.
It hasn't changed either. So right.
Okay. And I mean, the whole point is the evaluator has its hands off. But the whole point is if it is returned, if a structural expression is returned, how does that look in okay, so when there is if you were to somehow return a structural expression,
well, you just write a function that returns it.
Right. So if the return type is structural expression, as opposed to what is the return type when you are going to destructuralize a structural expression? Does that make any sense?
So the thing that we talked about before was if you have a function that has the type signature, you know, where it returns a structural expression, it'll just come out as an expression, a normal expression, and be evaluated.
Right. Exactly.
Okay, so this is something that really only exists in the compiler. It quote unquote won't ever return to top level.
Correct.
When
I mean,
you can
the
return
only
a
thing
structural
that we talked
expression to top
about.
level, you certainly can.
Well, right, but it just comes out as an expr, right? So I think the only thing that we talked about otherwise yesterday was what the behavior of these functions, structural expression, structural evaluate, should be in the top level. And we sort of agreed that structural expression, I mean, fundamentally, these things can't really work. But the idea was that structural expression maybe should just be hold all complete, you know, which is kind of similar to what it kind of does in the compiler. Structural evaluate, you know, we could have a version of structural evaluate that basically evaluates it and then returns another structural expression object. But yeah. I guess the point is that we could implement a lot of these things. Like we could implement a special implementation of reverse, you know, on structural expressions where it applies one level deeper, right? But we're not going to. So I don't know. I'm not sure how valuable it is to implement, you know, all these. I mean, it's not hard to implement structural evaluate, but I'm not sure if it's useful to have it because then people might want to use it and it just won't quite.
I think it's better to have people, if they want to return the structural expression without evaluation, they have to wrap a hold around it or something in their compiled code.
Right. Okay. So wait a minute. So then, how to determine how compiled code returns structural expressions? And the answer is, you can, within the compiled code, compilable code, use, hold, inactivate, etc. Right, that's the way it would look is it would say function compile of blah blah blah, and then it would say hold of some, you know, maybe it'll just be hold. I mean, this would be an example.
Well,
hold.
It would probably be construct. It would
You'd use construct with hold. Yeah.
Well, I think
why couldn't it just
this
be
might
that?
as well work. Yeah, this might as well work. There's nothing. I mean, hold should be defined to be able to take a structural expression, return a structural expression.
Yeah, it's just
hold on.
No,
Hold on. Right.
No.
In the compiler, this hold is, unless it has special behavior, it's going to evaluate its argument. So if I did x equals structural expression 2 + 1 and then hold of x, I would get back hold of structural expression 2 + 1, which is pretty weird. I mean, just hold on, you know.
No, I don't understand that. I don't understand.
I guess I see what you're saying. I mean, because basically, if you had something like hold of, okay, maybe an example would be hold of construct or a hold of, you know, apply f to these arguments or something like that, right? In the top level, that would return something with head apply. In this case, it would return something with head f.
Yeah, for example, yeah.
Yeah, it's attaching a special semantic meaning to hold within the compiler, which I don't think we want to do.
Yeah.
Okay, but we don't want people to have to. That's a very ugly. In that case, we should have a data type or something that's held held expression or some such other thing that can be the return type of a compiled function. Because I just don't think we want people having to type construct, hold. I don't even know whether that would work. I mean, that's a symbol, and do I have to wrap that symbol in structural expression?
Yes, probably.
Yeah, you do. Yeah.
Okay. I mean, this is very ugly.
It is.
Well, we could make a special function, which is structural hold or something like that.
No, but which I understand that, but the basic point is we've also got the issue of import, for example. Okay, import, reading something from a file, and I think it will be useful in some cases to let's say, I don't know, it's a JSON representation of expression, which would evaluate in the evaluator. Okay. Now we have the mechanism for import to return hold of something, but I think it would also be useful for it to be able to return a structural expression, whose only purpose in life is to be fed to compiled code. Because you wouldn't really be able to do anything.
I think it would also be a bit strange if what you're saying is that when you feed an expression to compiled code, if it happens to have the wrapper structural expression, it'll kind of take off that wrapper. I think that would be very weird.
Yeah, exactly. Yeah.
So, right. So asking my question, because I don't think I've gotten a clear-cut answer to it. So when we're saying that map and construct and whatnot support structural expression, that just means that inside a function compile, they act like you expect. Right. It's not that you could write map of f, comma.
No.
Like if you did map of f, comma, structural expression of 2 plus x, like that first input there, you'd end up with structural expression of f of 2 plus x, I presume.
No, I don't think so. I think it would should be treated as atomic.
Well, it would depend what f was. I mean, if f was a function.
It would
have to be a function.
Look, I think it's like a raw thing. I don't think we should allow people to, if we're, well, I'm not sure actually. Go ahead. Yeah.
But it is our expression. But the point is, when you return to the evaluator, what you're doing is you're calling the down code or the subcode for compiled code expression, and then that returns the structural expression thing. But then, because of the way our value works, it just automatically gets evaluated, and we can't prevent that.
I was a little confused, but can we go through one other thing, which is we were talking yesterday, and maybe we should bring up the notes for that. Does anybody know where are the notes from yesterday? They're in I don't think they were not on my screen. Christopher had them, right? That's why. Okay, but so we were talking about toString and things like that. ToExpression rather, and we were discussing the fact that there are sources of not yet evaluated expressions. Okay, and we talked about the fact that ToExpression is such a source, structural expression is such a source.
But so the input, right? So is your input cell or input
yes, exactly. Cell. Right, that is correct. That's correct. Except that the main loop, I mean, but that's the equivalent of ToExpression. It's effectively what the main loop is doing.
Right.
So import is another example. Template apply is another example.
Binary deserialize.
Yes. Okay, so these are all examples of sources of expressions that aren't yet evaluated. Now in ToExpression, we have the mechanism of being able to have a third argument where we're saying, wrap this head before you return the expression. So I guess I'm asking more generally what, another source, another source is the compiler. Compiled code can return not yet evaluated NYE expressions. And what we're discussing is what is the way of, just like toExpression has a way of wrapping a hold or something to protect the thing that was just created. What is the mechanism for compiled code to do that? And is it something that is said that is within the compiled code to determine, or is it somehow in the way that that's called?
Right. I would argue it's probably better for it to be inside the compiled code, because first of all, if it wasn't, it's probably going to be relegated to some obscure fifth argument or obscure option where it's just like.
And so far as the compiler is working everywhere, you'd have to have a wrapper for everything, and it would just be a big mess. Right. So I agree with you. Put it inside the compiled code, but the question is how.
Right. So the 0th way is the thing with construct above.
I hate it.
Yeah. I mean, the other question is will the thing always be hold or hold complete, or are there other kinds of wrappers that you'd like to have?
Inactive.
Right. But I mean, the point is sure. Although you could, if you had a held thing, you could probably inactivate it and so on. I mean, the question is, do we need one construct that basically just puts hold around it, or do we need some more general construct?
I think we need a more general
construct.
I think we need a way of saying what to do that is like the way toExpression has. Let me make another comment. What do we have for compiled for external? We have the notion of an external expression, right? Do we not? No, what is it called? An external handle. Like when you get in, you know what I'm talking about? Where you have a pointer. But when you have a raw pointer that comes back from a piece of Java code or something, you can store that raw pointer in the system, right?
You don't get
not really. The way that works is wait, sorry, are you talking about JLink, or are you just talking about how Java works?
I think pointers. There aren't any pointers in Java. There are
but there are references, so it's the same. So it's similar, or objects, right?
But
and you can pretend to get an object back from Java into Wolfram language. But what it actually is that JLink sets up a unique reference to it. So that when JLink goes back into Java,
doesn't matter. Doesn't matter. The point that I'm making is this: basically, we have, just like an external object, okay, is a blob. My gosh, this is pathetically bad documentation. It's a blob of external stuff whose only purpose in life is to be fed back to the external thing, right? Do we agree that's? I mean, this thing has no meaning.
Correct.
In our top level system.
Yeah. So similar to what I was just saying about the JLink thing.
Yep. So what I'm arguing is, I can see a situation in which you might want to do the following workflow. Okay. You might want to get a structural expression from importing something from a file and feed it to a compiled function as a pure unevaluated expression, just as a blob, just as an expr struct thing. Okay, just like, or similarly, you might want a piece of compiled code to return a structural expression that you do not want the evaluator to touch. Just want to put it on a shelf and feed it back to the compiled function again. You're just using the top level as a storage medium for that blob, just like you can use it as a storage medium for the external object.
Right. Or it's a bit like these data structures we have. It's just a structural expression data structure.
Yes, that's right. And what is the analogy? Okay, so there are some analogies here. Okay, so which is interesting. So an analogy, and what's the relationship? There's external object and there's data structure. And I could imagine, aren't there things with potentially with the external database kinds of things, which are also, are there other things here that are, things coming from entities, things coming from entity stores, databases, etc., are also things which are stored externally in a non-evaluated form but they might be stored as expers. We want people to store things as expers. We don't want the evaluator to mess with them. I mean, as I was saying yesterday, the idea of this WDF format that we talked about a number of years ago, one of its principal ideas was use expressions as the data structure, but keep the evaluator off it. Dan is also on our live stream is also pointing out, how does it relate to WSTP expressions? Good question. That's another good source of not yet evaluated expressions.
By the way, in WSTP, there's a thing called link read held and link write held, which I'm not sure how super documented they are, but they are attempts to solve this. I mean, they're sort of documented, but not totally.
Okay, so that's another example of where
those are not unuseful, actually.
Right, but so the general pattern here is there is an external program that is using the expr struct, but is not using the evaluator, i.e., well, there's a general category, things using the expr struct, but not the evaluator. See, I mean, right now, for the last how many decades, we've kind of bundled together the notion of the expr struct and the notion of the evaluator. And I think what we're seeing here, and what in a sense, when we're talking about held expression manipulation, we're seeing the unbundling of the expr struct and the evaluator. Is that a fair characterization? And I mean, so I think it's important that compiled code, okay, I claim it's important that any of these things be able to return a structural expression. And expecting that at the top level, the evaluator has nothing useful to say about structural expressions, just like it has nothing useful to say about external objects.
So they should return something wrapped in structural expression.
Exactly. And
here's another question about structural expression. Does it prevent lexical substitution?
That's a good question.
So if I do with,
that's a good question. I know, I understand the issue. Yeah. I understand how atomic is structural expression.
Yeah.
Right, and that is going to relate deeply to the things on this side here.
Another question is whether whether this structural expression is the same thing as the compiler thing, though. Because I think if we have this well-developed concept of a structural expression that's you pass around and do all these things with, and then we have this thing in the compiler called structural expression, but when you pass it in, like if the actual compiler, if a function that takes a thing of type structural expression actually just takes any expression, that's kind of confusing.
Well, I think it shouldn't. I think it should only take a structural expression.
But we need to have okay, but then when there needs to be another type.
We have to have a way of passing expressions into compiled code. Maybe that's purely internal, but we have to have that.
Okay, hold on. This is the problem. It's like quoting the quote. It's like unwrapping the unwrapper, whatever. Okay, so the issue is, and I think here we probably need to have some sort of diagrams and a little bit of a more formal approach to what the heck's going on. Because what you're saying is, I have a compiled function f, and I feed it an expression. And the question is that expression coming in? I mean, that expression is ultimately coming in as an expr struct object, is it not?
Yes.
To the compiled code. Okay.
Have a look at link write held. That's a bit like, do question mark on that. I don't know if there's any.
Not an impressive level of documentation.
Do question mark.
I've never seen something that has a message documented, but it's not self-documented.
There are plenty of those. Anything that's marked internal and DocuTools.
Yeah. Anyway, right. So this is a little bit like what you're talking about, except it uses a different function name and it uses hold. So I view this is not unuseful, actually.
So wait a minute. Why is this like, okay, link write held is making.
So it writes expr without the hold, but the hold is there to prevent evaluation. So I
feel like the way this is normally done by making link write held a hold all or a hold rest function. That's how most functions do this.
Yeah, but the whole point is being able to pass in a held object that has been passed around without exploding. That's the point.
Without having to do annoying things with width.
Yeah, exactly. Like exactly. Yeah. Yeah.
Sure.
Okay. So I agree that, I mean, the main point here is we need a way to pass around expressions without evaluation. We already have two such mechanisms, hold and inactivate.
And unevaluated.
But that's only temporary.
Yeah, it's temporary.
Oh, right.
Yeah.
But I mean, that's a similar kind of thing if you
unevaluated is an appalling hack.
No, exactly. Unevaluated is a cautionary tale.
And I'll also argue that inactivate doesn't fit because that's actually changing the expression structure.
Right, it changes the expression structure and it doesn't actually hold everything. So it doesn't hold the atoms.
I missed that.
What?
You broke up, Itai.
No, you go ahead.
Yeah,
he's complaining about the fact that the arguable design mistake that inactivate does not hold the atoms, does not inactivate atoms.
But I think for one of its design goals, that's very, like inactive integrates and things, that's very desirable. So.
Yes. Okay, but so what we're understanding is so how to feed stuff into compiled code, for example. And we're saying, okay, so basically there's the concept of auto unholding. Yes, okay, so this is the idea. So arguably, it could almost be an anti-hold attribute. Is this completely crazy? Okay, so here's the idea. So the idea is, just like link right held, you could imagine a function f where you pass it in f of hold 1 + 1, and that somehow what actually gets passed to f is the stripped 1 + 1. And that's what you want to have happen in the compiler, I think. In other words, you want to be able to, because that's what link right held does. In other words, you've either got, you either pass to the compiler.
So this is like quoting in a way. This is a bit like a quote function.
But it's an anti-quote, because what it's doing is it's saying, it's like do an eval on the quote. Because what it's saying here is, what you want is that in your compiled code, we want the ability to, we want a way to transport the, I won't say grenade, but some other transport sodium or something without it exploding after it's brought in from import. We don't want the evaluator to pour water on it, so to speak, and have it explode. But we want to just feed that thing directly into compiled code where it will be, handled correctly. Itai, you were about to say something, sorry.
Right. I mean, setting aside the compiled code issue, I mean, what you're expressing there, right, is that you want a way to automate replace of hold of x blank, hold of x per, hold of x blank goes to f of unevaluated of x, right? That's how you would implement this functionality now in the function that doesn't know how to strip a hold.
To say that again, I'll type
replace, hold of 1 + 1, and then comma, hold of x blank goes to f of unevaluated of x. Right, that's how you would that's a way to get.
Well, that's happened because f doesn't have any evaluation rules.
Right. Yes. Right.
Make f equals.
Well, I mean, if f equals.
Hold all. Yeah.
If f is something. It's just list or something here.
Well.
Why does that happen?
Because there aren't any evaluation rules. Make it f and do f x blank : equals hold of x, and make f hold hold all or something. Yeah, right.
Oh,
Fine.
I get it. I understand what you're saying. I don't want to.
I mean, these are the sort of horriblenesses about unevaluated.
Right.
I know. So this is what we're trying to deal with. So, what I think we need, and this is where we need to look over here at what we were discussing before. But the basic point is we need a thing. I'm claiming we need one thing we definitely need is a thing that stores exp structs that can be passed around at the top level and does not explode at the top level and can be passed back into, for example, okay, so here's a what can you do with a structural expression?
So part of the issue is that, I think if this thing is really 100% totally inert, the only thing you can do with it is unwrap it.
Well, what about export it? Why not be able to export it? If you can import something and get back a structural expression, why not be able to export it as well?
So I was just going to say, if the only thing you can do is unwrap it.
Can you type expert in there?
So the only thing you can do is unwrap it. It's the same as hold complete, which is fine. But I mean, hold complete, maybe we should just be talking about things.
Hold on.
Complete.
In export, you're actually going to export exp, not structural expression of exp.
Exactly. It's the same issue as auto unholding.
And then if we had a way of reading it in, then structural expression, it's not inconsistent with what we were talking about in the compiler either.
Well, that's the point. That's the point I'm making. That we need a way.
Right. No, it's a good point, I think.
Right, but this notion, which we are doing in a hacky way with unevaluated, of auto unholding. I mean, this is okay. So, what are the notions that we've got here? One notion is the idea of an exp struct object that can exist at top level. So, as I think Rob was pointing out, this is really like, this is similar to data structure. You could make this be data structure of structural expression, whatever, and you could actually, this is one sort of way of making a hook to create this thing, blah, blah, blah. Does that make sense?
Why don't we just make it whole? Yeah, you could do that, yes.
But that thing, go ahead.
Sorry, no, go on.
No, what I'm saying is that data structure here is just like in the compiler, and this would be a good thing to bring it out as a data structure, because
we could implement this as a data structure. It would take, like an hour.
Well, then do it.
Yeah, and what the advantage of implementing as a data structure is then you actually could have things like part work.
Exactly. You could have a limited set of operations work on it with nobody expecting that the evaluator is going to work on it.
Right. Precisely.
Right. Because
this is like super easy because it would just use expression.
Yes, I understand that. I understand that. And then we would. What is the most elaborate data structure here where we can look at its operations? I don't know.
KD tree.
Disjoint set is kind of
okay. Well, this has enough. Okay.
Yeah, they've all got quite a lot of stuff.
Right. But I mean, so things like length, we can perfectly well implement. We could implement a limit. I think this is a good stepping stone.
Right. And then normal would get you the expression, and it might evaluate.
Okay, but hold on. What we want, though, for the data structure version of this, we don't just want. So this is the weird case, because if we want normal of the structural expression data structure, that would normally evaluate. But we might want a version of that, just like to expression, so to speak. We want a version that doesn't evaluate. So maybe what that is data structure is this structural expression data structure of held expression.
Right, held expression would be the natural name.
Yeah.
Right, and then we could have another one.
I think this sounds fine, but the only issue is I think this. I'm not sure how compatible this is with using the same name inside the compiler.
Yeah,
right. Because if the type is called structural expression, and you're passing in something that isn't a structural expression data structure, and it's working,
this is useful.
Something is very weird.
It's a different thing from.
Well, maybe we should just call it. Okay, fine. Then maybe we should just call it expression.
The expression data structure.
No, that's too good a word. Data structure expression, or data expression, or
structural expression data maybe would be fine. I mean,
expression data.
Yeah, expression data would be fine.
All right. Okay, but needs a name.
And by the way, if you do head or part on this, you would get back another data structure, wrapping the head or part.
Actually, the obvious name here, which is a little bit grotesque, but would be expression data structure.
Yeah, that would be fine.
Mm-hmm.
Well, I think it's a little data structure of expression data structure sounds a little goofy.
Well,
yeah, right. It doesn't absolutely have to have head data structure. I mean, it could be the same sort of thing, but I think
it should be a data structure.
No, it should be
a nice framework.
I think it should fit in the data structure realm.
I agree.
Implement this.
Yeah, okay.
I'll implement this like now.
Okay. All right. Good.
Right, but I think the name is the name. Yeah. I mean, all of these are data structures. Stack is a data structure, but it's not called stack data structure. It's just called
Correct.
stack.
All right, let's call it, okay, this is crazy, but let's for now call it expression structure.
No, because then we have structural expression and expression structure.
Okay,
no,
right.
no.
What else would you like to call it?
Expression data.
I think expression data is good.
Why do you want to call it expression data? I don't understand what that even
or
means.
Expression handle or reference or.
Well, I think expression data is good because what it really is an expression is something that's evaluated, and expression data is kind of the data before it's been evaluated.
I'm not believing that, but go ahead and use that for now.
I mean, there's a certain Lisp, code is data thing that I feel like that's also violating maybe, but yeah.
Right.
Honestly, I think it's just expression is.
No, because it's a type. This is going to be a type. An expression is a good name.
We don't want to use expression for the.
We don't want to use a good name for this. Yeah.
Wolfram expression.
Well,
that's just.
What was wrong with expression handle? I think Tom had suggested.
Well, it's not really a handle, right? I mean,
there's nothing handly about it. Right there.
It's
right there.
Especially now.
Although maybe one question, maybe it is okay. A lot of these data structures have mutable operations.
Right. Well, they don't have to. Not all of them. There are immutable ones. There's an immutable vector.
This could do.
It could be perfectly
have mutable operations. Take hold of
on. No. Please. No.
Oh, yeah, fine.
If we start mutating it, expressions like this, we'll get terrible consequences. Please.
So the question is though is if
we'll have hash tables that become invalid because you mutated the thing and the thing stored isn't.
No, you're absolutely right, Tom.
Yeah. No.
So I mean, the question is, it's okay. So you're saying that if we had, let's say, a set part operator, that this set part operator, you'd run it and you'd get a new expression out, and
the old could do that. Sorry, excuse me. Yes, but that's redundant because expression is immutable.
Well, what about append? What about append? Would append create a new expression?
Yeah, why not? Why not?
It should do.
Could it modify the existing one, or would that?
Of course, it could do, but please,
that's a disaster.
It'll be disastrous.
Okay, fine.
Right. Not immutable expression. That's terrible. Sorry.
Expressions are usually immutable, so
exactly.
Dan Livestream is suggesting expression state. I don't know whether that really works. Quoted, I don't think so, because I think quoted. Well, some of these things are sort of foreign. Actually, what about expression content? That's kind of crazy.
What about expert?
That makes it sound like it doesn't include the expression itself. It just contains the contents.
Sorry, Jose, you were saying something. What?
Just expert?
Oh, that's an interesting idea.
I think that's also a good name. Sorry.
I don't think that's that good a name.
One thing that could be confusing with it is if we do have and part of the reason why we don't just do expression is because we want to save that name as a type name for the compiler. If we ever had expr and expression, that would be pretty confusing.
Yeah. I think this is a slightly niche thing. I mean, a long name doesn't.
What about calling it expr struct? I mean,
that would be fine.
If we've got branded names, like, we've got plenty of branded names like Bloom filters and things here. This is the thing, we know it as ExpaStruct. So let's call it ExpaStruct.
Fine. I like it.
Yeah, that's great.
Okay.
Right. It will be.
Okay, fine. So now the question is, given an ExpaStruct data structure, then it would be a type in the compiler called ExpaStruct, right?
Correct.
And which is different from the structural expression.
Correct. Yes.
So if you have something that has an input type, if you have something that has the input type ExpaStruct, it is expecting an ExpaStruct data structure. It will not just take a normal expression or anything like that.
Correct.
And similarly, if you're expecting a structural expression, you can give it an ExpaStruct, but it's not. It's going to show up with head data structure or whatever.
Yeah.
Right.
Correct.
Okay.
All correct.
Okay. So now let's look at. I'm still confused about auto unholding and what the generalization of unevaluated is, because there's this question of if you feed in a. Okay. So wait a minute. This is the data structure case. If you feed in a structural expression into a piece of compiled code, you want a way to have I'm claiming that perhaps we need an attribute that basically is an unwrapping attribute, just like in effect, so that's what I'm claiming is we need should we have, actually, there's another possibility.
But I think there's a problem with this, Stephen. This unwrapping attribute would work fine for stuff that has down code, but what about in down values? As soon as you unwrap it, it evaluates.
Well, not if it's compiled code.
No, not in compiled code.
Hang on. What does the attribute go on? It goes on to
the function. Well, okay. So this is assuming a down value situation. So I agree this is probably not a good idea. But my question is, it would be very nice to be able, given a compiled function, given a function f whose value is compiled code, can we type in f of structural expression of blah, where we've got that structural expression from importing a random piece of JSON or something, where we just want to
as XXX.
What's that?
And have it show up as XXX.
Yeah, have it show up as 1 + 1.
Yeah, fine.
How would we do this?
Well, we could just say, if it's structural expression and you put another level, you put structural expression of structural expression, if you really want an expression that is structural expression.
What?
And the same, supposing I wanted to get in a JSON file, actually get structural expression there. So you would just put double, it's like quoting the quote.
Mm-hmm.
So write double up the structural expression.
You mean, okay. So you mean you want 2 levels of it?
Yes.
Tom is suggesting that if f is a function that expects a structural expression, it will auto strip 1 level. So
that's exactly yes.
In the first case, f will see 1 + 1. In the second case, f will see structural expression of 1 + 1.
You got it. Yes.
Oh, I mean, you mean if you needed to feed in an explicit structural expression, but you would, but I don't understand. We've got 3 cases. Okay, I type in, let's say it isn't 1 + 1. Let's say it doesn't have an evaluation issue. Let's say the thing was just, list 1 1, for example. Okay. Then what gets passed into the compiled code? So the data type of what's coming in would be let's say in the compiled code that this is a function where it is, I'm not sure I know how to do this properly, but typed of x, structural expression.
Yeah. I mean, you could write expression now, and that would work. So, yeah.
Well, but do we want? Is it expression or structural?
No, right now it's expression. It will be structural expression.
Yeah.
Okay. All right. Okay. So then then this thing here, if I type f of 1, 1, or if I just feed this, function 1, 1. Okay, let's consider this case, right? Then what goes in there is it just goes in as a structural expression and it does what it does. So for example, here I could type length of x here, and that will be a compiled, assume this is a function compile of this, and that would just work and give a result 2.
Yes. Get rid of the structural and evaluate it. It'll probably, I think it should work. You'll get
That'll take 10 minutes, Tom.
Well,
it'll take like
only take 5.
I think it'll take like 10 seconds.
It has to launch the
Get out
compiler.
my stopwatch.
Oh, okay, right.
I need my stopwatch. Oh yeah, I've got a new stopwatch here.
Okay, well.
What? Oh, I haven't even had time to
Right,
get up.
I counted 13 Mississippis.
Do that again. Sorry, it was launching the compiler. Do that again.
That was much more respectable.
Yes.
Okay, all right, so this just works. So that's great. So now the question is to have, I'm going to change that to structural expression just to see what it would look like. Let's say this was structural expression. Should this just work? You are proposing that it should just work. I don't see an objection to it just working.
And that would return 2.
Yes, because
or 1 plus 1 plus 1, and it would return 2.
Yes, that's correct. If that was 1 plus 1, it would still return 2.
I think that's a bad idea. So basically what we're saying is that the question is, how does the compiler process the expressions coming into it before it, runs the code on it? And basically what we're saying is that it doesn't do anything unless it has head structural expression.
Yeah, you're probably right.
In which case it removes one level of structural expression.
You're probably right.
Well, no, but this is look.
So I don't understand. Oh, right. So the point of the structural expression.
The thing is, it is like an external object. It came in, it is a pure expastruct thing. It is not making use of the evaluator. It is purely structurally an expression. It is not, it is not evaluationally an expression.
So I think the way you would do this is, we just talked about this expastruct data structure. You would just pass in the expastruct data structure, and then for your typed of x, you'd say typed of x comma expastruct. If you're talking
so wait a minute. So then you're claiming maybe import should be able to return an expastruct data structure.
Yeah, I would say so.
Actually, that's not crazy.
Yes, instead of so that's the alternative to this notion of a structural expression.
And in fact, that sort of solves your hold problem. So instead of using hold of expr in something, you just pass some function in expastruct data structure, and then it can decide how to evaluate it when it wants to.
Yeah, well, the expastruct data structure is deeply not an evaluation story.
Right,
and so I see. So then the idea would be, we would be able to say import of file.wxf, and then the element would be expastruct.
Right.
And then that would return.
And if you export it, it exports the unevaluated expression.
Well, you export the data structure. If you're doing this, if you say export.
This is super interesting. I want to go and implement.
Yeah. I think it's going to be great, Tom. It's easy to implement too.
Yeah. It's really easy.
That easy.
Okay.
Right. So if we're just going to have the data structure, do you still want to call it expastruct, or do you want to call it structural expression?
We possibly could call it. I kind of like expastruct. It's a low-level thing.
Yeah.
What we all call it.
Yeah.
And it's a little slangy, but And Sander on live stream is complaining that it sounds MATLAB-y.
No.
I don't know. I don't know that.
You don't know what that is.
My standard for these things is schoonship, where the main operation was where all the mnemonics were in Dutch, and I think YIP was one of
Lots
the.
of type theory. There's lots of Dutch and Flemish type theory people.
Is that right? Do they have are there keywords?
De Bruijn, like De Bruijn indexes and things like that.
De Bruijn,
Yeah.
I think. I don't know how it's said.
Well, it sounds like a Dutch or Flemish name. So.
Well, he was a long-time Philips operative.
Yeah. Well, Philips.
Did lots of interesting things.
Yeah.
Yes, including the system called Automath, which was an early theorem-proving thing.
Oh.
I never met him, unfortunately. Anyway, let's see, where were we here? So, all right, so the export case, what one will be saying is, if one wants to have a not touched by the evaluator expression structure, then make it an XPER data structure. That's the basic message here. And that means potentially some of our operations on unevaluated code could be done by simply turning. Okay, so here's a question. How do you turn? Okay, so now we have create data structure. And we want to be able, this is again an auto unholding question.
Right. So you would do XPER as the first argument.
Yeah, but then what? Because I want to pass an expression. I want to have something that I typed in.
Right. Then you would do like part 1 at the end of it.
The end of what?
You would type that, and then at the end you would that would return a data structure handle to hold of XPER, and then you could strip off the.
That is a hack. That is a ridiculous hack. You'd say that.
Well,
is that what you're saying?
It would work.
Yes, I know it would work, but it's not a good way to do it, I think.
I'm not sure you'd want to create data structure hold rest for this.
Yeah.
No, you don't. You definitely don't. You want to be able to carry an expression around in. I mean, otherwise.
At the same time, you would not want it to be the case that this thing just strips off holds or hold completes or something like that.
No, but there's something. Okay, look, it needs a wrapper. Okay, the basic problem is I want to be able to type an expression using the parser where I'm, again, it's how do I get an expression that is a not yet evaluated expression? Okay, the number one way is use the parser, right? Because that gives you an expression which, when first created, is not let's see, when it's first created, it hasn't been evaluated, but you want to use the parser to type this stuff in. So the question is, if you could have a different form of hold that would be stripped by create data structure or by, look, the other possibility is, how to do this.
You could have an additional argument that says, that's like an option, strip hold.
Well, you could just have a, no, it has it's varargs.
Yeah.
Okay, but the other point, by the way, is the XPER data structure could have a print form that looks a lot like the expression. That would help for many purposes. Do you see what I'm saying?
It certainly could.
Sure.
That would make it unique. The other data structures have a sort of, data, if you look in the, so you don't want it to look like that.
I'm suggesting that it says data structure of, and then it actually shows the expression here. Because we have a way to show an expression. We don't have a way to show a length 5,000 linked list or something. I mean, it can show a kind of impressionistic version of the expression. Like if the expression is very long, just show ... dots, things like that.
Fine.
I mean, it probably needs some design. It might need to say, it might have a little thing up at the top that says expr struct, and then it would have the actual expression. And it should probably have the data structure over a wrapper. Maybe we'll change our mind about that. But okay, we have not solved the problem of how do you, I mean, this is the analog of the E function in internal code that creates an expression by using essentially the parser, but as a pure expr struct.
I'd argue that there's E and there's also apply. If you have, because those are the two kind of cases you need. One of them is the case where, right. I mean, basically, if you have a fixed, if you have a small number of arguments versus if you have a lot of arguments.
Okay, but that, fair enough. Yes. But I mean, okay, so we have an unsolved problem here, which is how to create an expr struct.
Well, suppose you have an expr struct containing the symbol F, right? Maybe you can say, of quotes apply, and then I don't know, give it a list of other expr structs and it will apply to those.
Yeah, why not?
Or give it an expr struct of a list and it will apply to that. Or there's also a question of the direction. Should the apply operator be on the F or on the list of expr structs?
Yeah, well, that's, I mean, yes, but this is where we have to invent a whole sub-language. And pretty soon we're inventing something which is like an expression manipulation language. So sure. I would claim that the right thing to do would be, okay, so I'm going to make a claim that we should be able to do something like this. Where that actually is an arbitrary expression. That's kind of weird. I mean, take that out, and this is some kind of, I don't know what this means, but
maybe do a different apply function from apply.
Yes.
I mean, the standard, by the way, with data structures is that there to be a comma, not an arrow.
Yeah, yeah.
Right. So what that would do is it would take this thing and it would insert it. It would spray it into the expr struct without evaluation. Right, so if this is expr struct of
it would
1, 2,
return
3,
a new thing with
would return a new expr struct that just says total.
Yeah.
Wrapped around 1, 2, 3.
This is great. This is great.
It's a bit weird to call it apply function. I mean, I understand why, but right, it's not apply in our sense.
Why not call it construct? Actually, call it apply.
Construct. No, apply would be something different. Apply would be total of 1, 2, 3.
It's mapping.
This construct, by the way.
Yeah,
it's apply at level 0, but construct
map at level 0.
Yeah.
Isn't it also apply at level 0?
It is, yeah.
But this, by the way, that's not a good use of construct. Like that's back. You'd expect that to work if the expr struct contained total, and you were constructing all this other stuff.
Just say apply function for the time being. But this is
why isn't it apply?
Because apply would give you this, and what we want is total of 1, 2, 3, like this.
Oh, sorry.
You're thinking of wrap. It's like you're wrapping it.
Yeah.
Right. So why is that not a good use of construct?
Yeah, I don't understand why that isn't exactly construct.
Because it's sort of backwards. I would expect that construct, you'd have the F, you'd have the function name as an expr struct, you'd have the head as an expr struct, and then on that you would say construct and give it its argument.
It's as if we had E operating on an expression, which would be just totally bizarre. I mean, E operates with expression arguments versus operating with some expression in mind when you use E.
This is feasible.
Okay. And anyway, we should solve this, but the thing is, well, let's get this thing implemented. Let's get the expr struct data structure implemented, and then let's start
I've started
even as we speak. Okay, and then that's always a good sign with Tom when he's in. Okay, but then then feed in, just put in a big collection of random methods, functions, whatever, and then let's look at what what we can do with them. But I think we're still.
But by the way, these things will work in compiled code as well. Just I've worked very hard. So whatever you write here, you can write that in compiled code. So
no, I understand that. Although this would be in compiled code, you could also write regular top-level code that is then compiled and will do these operations. Yeah, I mean that's I still think that there's going to be value. Well, okay, so the question really is this our way of carrying around a purely structural expression? Is this our sole way of doing it, an exp_struct? And it could be.
Yeah.
But that's what you get. So let's look at our sources here. Okay. So do we believe, for example, that we should have just down here? Okay, so we believe, for example, could toExpression of 1 + 1, comma, exp_struct. That would be a thing we would have to support. Anybody got an objection to that?
No,
I think that would be fine.
I object to that. That is right. I mean, the second argument is a format type. This is not a right. It tells us, tells you how
it's a format type.
It's the third argument.
Oh, sorry. Okay, so this is standard form exp_struct.
Okay. So use it as a magic string, which it's a short form of data structure of exp_struct, comma, pound.
Well, except that, notice that. See, the important point is that create data structure is not hold rest.
Right.
So the alternative here would be to have an actual structural expression thing that is a wrapper that is equivalent to create data structure. I mean, that's another possibility. To have structural expression be a function that evaluates to a data structure of an exp_struct.
Wait, but now I feel like that's very strange.
That's different than how it's used in the compiler. So,
right. I mean, so far these have been totally unrelated.
Wait. So is structural expression something that exists in the compiler already?
It's called expression.
Kind of, yes.
Yes.
And what it is, Itai, is something where it does exactly what we're now talking about, which is structural expression of 1 + 1 uses the parser effectively to parse the 1 + 1, but without evaluation, and simply turns this into an exp_struct.
It doesn't really use the parser because it's already been parsed. It's in a function.
Well, fair enough.
But when you say it turns it into an exp_struct, critically, you mean it turns it into it does not turn it into the data structure exp_struct. It just turns it into
an expression type. You muffled, Christopher.
Yeah.
Literally the expression exp_struct.
Yeah, it's binary compatible, ABI compatible with the kernel. Yeah.
Right, but so again, I don't think so. So within compiled code. See, I think these are, again, maybe there is a worthwhile concept of toExpression having, this is the question we keep on asking. How do you parse, if we have structural expression of 1 + 1 can appear in compilable code, it does nothing as such other than when the compiler ingests it, it turns that into the internal expression, structural expression type. Now, the question is, what if structural expression were to get released to the top level? Well, right now we're saying it's atomic and it does nothing, right? So the only question is...
Well, kind of, again, what do you mean by, if by release, do you mean I have something with type structural expression, I return it to the top level? What we're saying right now is it comes out as the expression 1 + 1 and it will evaluate and turn into 2.
Yes, if it is being released by the compiler through its normal channels. If I simply copy paste the code, I can
fine. It's just hold all.
Right. But I argue, okay, that on the way out, structural expression is stripped by compiled code. But on the way in, we're saying there isn't a way to strip it. So in other words, Okay, so compiled code effectively strips structural expression on return. On input, what would happen if you fed, on input, what does f of structural expression 1 + 1 do?
I really think it creates a structure. It creates a structural expression in the compiler with head structural expression, as opposed to with head plus.
Yeah, I
okay, but I think it is useful, and now we're going to get into an unevaluated hack. It's useful to have some way to be passing around. You got it from your importing your JSON file, you got it from a deserialized, whatever. You have a thing that is a structural expression at top level, and now you want to pass it into the compiler.
Yeah, and I'm not convinced that just stripping the structural expression is totally incorrect. Because what happens if you inside of a compiled function you write structural expression of 1 + 1? Now that structural expression gets stripped, right? So if you wanted to construct a structural expression with head structural expression, you'd already have to use the double quoting. So why is that inconsistent with arguments?
I mean, I think
I agree. It seems not crazy to me to have this auto stripped.
I'm just slightly worried about these things where it's like, we say, oh, you're passing in any expression here and you're going to get the exact expression. And, if you're doing symbolic manipulation with it, it's all going to be safe. But then, oh, well, wait, whoops, you passed in the one expression that gets manipulated. Like, I'll give you an example, right? One of the things I was playing around with, a while ago was with, optimizing and close confirm. And I wrote something which I might have otherwise written in, kernel C code, which is sort of a bad idea, but just, traverses down the expression, finds the confirms, replaces them, etc. Right. And so imagine if I wrote this, if I wrote this using this, then there might be certain magic expressions with head structural expression that you could pass into this function that would end up getting mangled.
Yeah.
Right.
Okay.
And in particular, they would end up actually evaluating, because they would come in as a structural expression, which is held. And then when they get returned, that structural expression would have been stripped. And so they'll suddenly evaluate in this dangerous way. Right. I mean, this is the thing is I think if one of the main applications of having compiled functions that accept structural expressions is that you can do very safe, low level manipulation of exprs, then if they can sort of get somehow magically unwrapped, that's very scary.
We ran out of time here, but we had a lot of good stuff to discuss here, and we should probably pick it up next time. I think this was very useful. I'm trying to remember what. Remind me, what is this? This is.
So this was an idea that could be just for map, or it could be for both map and replace. Right, you want to insert something and you want to insert it evaluated, but it's inside of a hold, so it wouldn't normally evaluate, right? So you have, well, just a stupid example, right? You have hold of 1 + 1, or you have hold of a list of 1, 2, and you want to square everything, but still, keep it inside the hold.
Right, I remember this issue. So in a map, the question is, the map normally, so this is very similar to this issue, actually. It's a similar issue here. And possibly we could even use the same mechanism. Because what you're saying, this is the immediate evaluate mechanism. And what you're saying is map of immediate evaluate of hash squared or something like this on hold
of 2.
Well, actually, the map.
No, just do hold of 2. That'll be good enough, right? So, right, that would give you hold of 4 as opposed to hold
Well,
of
what
2
if you did
squared.
this at least? Right, because the map is just at level 1.
No.
Now you're going to be squaring the
No,
whole.
you don't want the list, right?
Oh, I want. You're saying I want.
No. Just evaluate that. No list. Just 2.
Why? Why would this work?
It
Right.
would apply the pure function to 2.
Right. So just do pound squared. Remove the immediate evaluate and evaluate that, and you'll see what you get.
I know what I get in that case. I mean, I get hold squared.
No, you don't. You get hold of right. You get
right.
So
hold
you want the pure function expanded out, but not to evaluate.
No, it should give hold of 4.
Right. That's what the immediate evaluate should do.
Yeah.
Right. And I guess this is because this is function of function. So
what do you want from this Itai? So, sorry, I'm confused.
Let's not cover this today.
Right. Well, just the point is that this would give you hold of 4 rather than hold of pure function of 2, which is what it currently getting at.
Right. I claim this is not.
It would rather than just inserting the things at each place, it would insert eval that part and then insert the evaluated expression.
Right. I'll implement that as a method in XPerStruct data structure. It's pretty trivial. So
fine. Okay, but I mean, I'm telling you, this is not completely unrelated to this whole question about passing in structural expressions.
No, there are definitely connections, and we'll need to continue this some other time.
Sounds good. All right. Thanks a lot,
good
guys.
stuff, everyone.
Yes.
Hey Tom, sorry to cut in, but Tom, do you have 5 minutes to join my Zoom?
Yeah, sure. I can come over. Yep.
Okay, thanks.
Okay. Thanks to folks on the